a function y equals fx whose domain is d1 and y is equal to gx whose domain is d2, then the domain of the common function fx plus gx is the intersection of the domains d1 and d2. That is, the common domain, the domain that is common to both the domains d1 and d2 would be the domain of the function fx plus gx. Repeating again, if d1 is the domain of the function fx and d2 is the domain of the function gx, then the common domain of the function fx plus gx is the intersection, the common interval between d1 and d2. The same goes for fx minus gx also, and the same goes for fx multiplied by gx also. So for example, if we have sin x multiplied by 1 by x, sin x by x, so the domain of this function should include the domain of sin x as well as the domain of 1 by x. So what is that? That is all real numbers except 0, because sin x has the domain of all real numbers. However, 1 by x does not have 0 in its domain. So therefore, the domain of sin x multiplied by 1 by x would be all real numbers except 0. The same goes for fx by gx also. So if d1 is the domain of fx and d2 is the domain of gx, then the domain of fx upon gx is all the numbers between d1 and d2 except those which make the denominator function gx as 0. Even though 0 may be part of the domain of the function gx, however, in the composite function fx by gx, we are not allowed to make gx 0, because if we remember, division by 0 is not allowed. So therefore, the common domain of the functions fx and gx is d1 intersection d2 minus the value of x where gx becomes 0. So we will do more examples of this case later on.